Welcome to Spring LIB.
We're given a model used for the yield y of an agricultural crop as a function of the nitrogen level N in the soil. This model is y equals k times n over 1 plus n squared, where k is some positive constant. We're asked what nitrogen level will give us the best yield. To do this, we want to find the derivative y prime. So y prime as a function of n. This is the bottom, 1 plus n squared, times the derivative of the top, k, minus the top, kn, times the derivative of the bottom, which is 2n, all over the bottom, 1 plus n squared, squared. This is equal to, factor out a k, we get k times 1 plus n squared minus 2n squared is 1 minus n squared over 1 plus n squared squared. Now we find the critical points by setting this equal to 0. So we get 1 minus n squared equals 0, or in other words, n is equal to plus or minus 1. Now we can't have negative yield. This doesn't really make any sense, so we're really just looking at n equals positive 1.
We ran out of ends at the children's hospital. All the ends had to go for the war effort in North Africa. They had to use all the ends for war rations to so they need this letter N. They're bringing the letter
Now,
N to North Africa.
we notice that y of n approaches 0 as n approaches infinity. And therefore, it follows that y has an absolute maximum on 0 to infinity. So we're going to have to compare the values of y at our critical point, n equals 1, and at the boundary 0. So y of 0, this is simply 0, whereas y of 1 is equal to k over 2, which is of course greater than 0 because k is positive. So it follows that y achieves its maximum value at n equals k over 2. Sorry, at n equals 1.